meadows ring. When I was born, joy burst free.
Welcome to the Voice of Autism Resource Hub. Today, we are excited to introduce modern special education for children with autism that is shifting from a subjective observational model to a data-driven model through a combination of artificial intelligence, AI, and digital twins. This combination addresses the core problem. Each child with autism is a unique universe with inconsistent sensory thresholds and cognitive paces, causing traditional static educational programs, IEPs, to often lag behind the child's actual development.
Where hope will stay. Mother dreams of clouds soft and bright, a horizon glowing with radiant light. The river no longer flows in reverse, tears turn to stone, a path to traverse, paving the road for my journey to Rome. Her love's the guide that will lead me home. I lie close, I feel her care. Her love's a whisper in the air. Through clouds of dreams, she sees my way. A sky of light where hope.
Welcome to The Explainer. Today, we're diving into two incredible frontiers that are set to completely change the game for autism support. We're talking about a shift away from, well, guesswork, really, and moving towards something much more precise. Every autistic child is a unique universe. You know, this one idea, it's really the heart of the whole challenge, isn't it? It's our starting point. The autism spectrum is just so incredibly diverse. Every single child has their own sensory triggers, their own way of thinking and processing the world, so it's no surprise that a one-size-fits-all approach just doesn't work. It just can't. So for a long time, what have we relied on? The traditional special education plan. But let's be honest, these plans are often kind of static. They're based on observations that happen every now and then, and they can be pretty subjective. The big problem? They're just not built to keep up with what a child needs right here, right now, in this very moment. So, the big question is, how do we build a system that can actually listen? A system that adapts on the fly? Well, that brings us to the first frontier we're going to explore. And this is really important. It's all about using technology, not to replace that crucial human connection, but to make it so much more powerful. All right, let's get into the nuts and bolts. A personalized digital twin, or PDT. What on earth is that? Think of it like a virtual copy of a child's cognitive and biological state. It's created by pulling in real-time data from sensors, stuff like heart rate. Now here's where it gets amazing. It can actually predict when a child is about to experience sensory overload. So imagine a classroom getting a little too chaotic. The PDT could send a quiet alert to the teacher's earpiece that says, hey, now's a good time to offer those noise-canceling headphones. It's basically a digital interpreter, translating what's happening on the inside before it becomes a crisis on the outside. So the PDT is one piece of the puzzle. The other piece is something called a digital peer autism, or DPA. This is the part the child actually interacts with. It could be a cool little social robot, or maybe an avatar in virtual reality. The whole point is to create a safe, predictable, and totally non-judgmental space to practice social skills. Things like making eye contact or taking turns in a conversation can be practiced over and over without all the anxiety that can come from unpredictable human interactions. Now here's where the magic really happens, because these two things work together in this incredible adaptive loop. Think of it like this. The PDT is the brain. It's constantly crunching that real-time data to figure out stress levels, focus, all of that. Then it tells the DPA, which is the interface, how to adjust. So if the child is getting stressed, the DPA might lower its voice or simplify the lesson all on its own. And all of this practice in the digital world becomes the foundation, the scaffolding that helps the child bring those skills into the real world with other kids, with a teacher right there to guide them.
And I mean, just look at the difference this makes when you put it side by side.
On one hand, you've got the old way, subjective observations, reacting to a behavior maybe months after the plan was written. On the other hand, you have this new model, real-time sensor data, predicting a crisis before it even starts. The environment can be adjusted instantly, and look at this intervention lag. We're going from months or even semesters down to less than 3 seconds. It's a total shift from being reactive to being proactive. It's a whole new ballgame.
So everything we've talked about so far, it's all about adapting the outside world to the child, which is amazing, right? But what if we could go even deeper? What if we could intervene at a more fundamental level? This leads to a completely different but just as revolutionary question.
And that brings us to the second major frontier we're looking at today, gene therapy. This is a biomedical approach, and the goal here is to see if we can address the underlying biology, to fix the issue right at its genetic source for some very specific and severe forms of autism.
Now, a lot of this research is based on the incredible work of people like Dr. Alison Moutry, and we have to be absolutely crystal clear about something. This is not about finding a cure for all autism. It's not that at all. What we're talking about is a highly targeted medical treatment aimed at correcting specific single gene mutations that are known to cause some of the most severe forms of autism and related syndromes.
So how do you even test something like this? Well, it's pretty futuristic. Researchers are using things like human stem cells to grow what are called brain organoids. I mean, they're basically miniature lab-grown brains. It sounds like science fiction, but it lets them safely test these therapies on human-like brain tissue for conditions like Rett syndrome or Pitt-Hopkins syndrome, without ever involving a human patient. And of course, the very first step for anyone would be genome sequencing, to see if they even have the specific gene mutation that these therapies are designed for. Okay, let's just pause and underline this because it is so important. This approach is only for severe cases tied to specific gene mutations. This is not for high-functioning individuals. This is not about changing someone's personality or who they are. It's about a potential medical intervention, plain and simple, aimed at helping those with really profound challenges caused by their genetics.
All right, so we've looked at two very different paths, haven't we? One is all about AI and education, and the other is deep in the world of genetics and biomedicine. They seem worlds apart. So, how do they connect? Well, they're both driving toward the exact same goal, getting away from the one-size-fits-all mindset and embracing true personalization.
The key thing to understand is that they aren't competing ideas. They're complementary. Think of it this way. The AI and digital twin approach tailors the external world to fit the child. It's about support and can be used pretty broadly. Gene therapy, on the other hand, aims to correct an internal biological issue for a very specific targeted group. One works from the outside in, the other from the inside out. But both are fighting for precision and personalization.
Now, as exciting as all this sounds, we have to be realistic. These are huge, groundbreaking ideas, and turning them from a possibility into an everyday reality, well, that comes with some pretty significant hurdles. So for the AI and digital twin approach, the challenges are huge and systemic. First, policy. We're talking about incredibly sensitive biological data, so you need rock-solid privacy laws. Then there's infrastructure. How do you get this tech into every school and make sure it all works together? And maybe the biggest one, training. This changes the role of a teacher from just being an instructor to being, well, almost a strategic data manager who can use this information effectively. And of course, all of that takes funding.
And on the gene therapy side, the hurdles are just as big, but they're mostly scientific and ethical. Number one, above all else, is safety. You have to be absolutely sure these treatments are safe. Then, there's a huge technical challenge. How do you effectively deliver the therapy to the exact brain cells that need it? And looming over all of this are the massive ethical questions. We're talking about genetic intervention, and that's a conversation society has to have very, very carefully. When you take a step back, both of these frontiers represent a truly monumental shift. We're talking about moving away from a system that's based on reaction and guesswork to a future of support that's proactive, that's driven by data, and that is deeply, deeply personal. It's about finally being able to tailor support to the unique universe of each child. The science and the tech are moving at an incredible pace, and that leaves us with one final, very big question. Are we ready for it?
Full of worry, a void to fill. The river flows back, tears in streams, to quiet springs where sorrow dreams.